Okay, so I'm going to talk about waste. Hopefully the talk won't be an example of it, but you'll tell me at the end. I'm going to talk about some of the things that Carlos already talked about, because when you adopt uh, uh, remote working, it's very easy to fall into certain types of waste and not realize it. So the point of this talk is, on one hand, to make sure that you're aware of the waste that you're incurring in. And also another motivation for it is that I've read and heard a couple of times that lean software development and agile software development are not compatible, which I hope that it's a myth that I will dispel in this talk. So the lean software development is, and the concept of waste, the specific concept of waste that I'm going to talk about, has its roots in lean manufacturing, which is something that came out of Toyota in the during the 20th century. So mainly after the war, but it's something that was developed over time from the start of the century, back when Toyota was a textile company, which it's not something that a lot of people know about. I certainly did not know about it. It's the Toyota production system that gave rise, to the ideas of lean and waste. It's settled on a couple of core philosophies of respect for the people and continuous improvement, and it's something that, interestingly, it's something that I also pushed in both directions, both toward the side of the customer and toward the side of the suppliers. So they encourage suppliers to continuously improve, and they also encourage the customers to continuously improve. And two operational principles, which are just-in-time manufacturing, which is building stuff when it's needed, as it's needed, and a concept of automation, which is not exactly automating production processes. It's about automating the quality control checks. And there was a good example happening very early on in Toyota, when they had these looms that they were building, fabrics and carpets and whatever. And whenever a thread broke or whenever there was a problem, the machines would stop, and it would force people to look into the problem and solve it as soon as possible. So out of these core philosophies, they started to define and systematize a few definitions of what kind of wastes exist in manufacturing. So I'm going to talk a bit about these wastes. So there are three main categories: muda, mura, and muri. One is wastefulness, which is mostly what I'll be talking about. The other is inconsistency, which is if you're not, consistent in your production, you increase the chance of making mistakes and introducing defects into your products. And another, which is unreasonableness, which is very closely tied to the respect for people, for example, where you don't push people to work harder than they can, or you don't push even equipment to work or to operate harder than it can, because it causes stuff to break down and causes people to break down as well. So the wastes of lean manufacturing are 7 originally, and then another one was added. They're transport, inventory, motion, waiting, overproduction, overprocessing, defects, and then the 8th one that was added later on, which is not really a core one, which is skills, human skills. So transport. Transport is any waste that comes from moving stuff around. Could be equipment, could be products, could be tools. And whenever you move stuff around, the chances are that you're going to break something or lose something, or you're going to deteriorate something. So you try to avoid moving stuff around, and even people or knowledge, which is going to be very relevant in our case. Inventory comes from storing stuff that you don't need to store or shouldn't need to store. So it could be that you've ordered too many items, too much raw material from a supplier, and now you have to pay for the warehouse and you have to keep it around. Or maybe it's something that's perishable, and if it's perishable, maybe in 1 month you'll have to throw it all away. It could also come from producing too much. So and then you can't sell it, and then it's just piles up and causes you to pay extra for. There's motion, which is mainly from asking people to do stuff that's not really useful and that's not really productive. Either something that could easily be automated, or going to meetings that don't help anyone. There's waiting, and this waiting can be caused by any other waste even. So if your people are held up, doing useless work or in a meeting, others are waiting, they're not doing their jobs. Waiting comes from any place, and whenever you're stalled, like you're generating this waste. Overproduction, probably the worst in lean manufacturing. It comes from producing something before it's needed. So you produce a bunch of stuff, you're not able to sell it, and again, imagine you have a food processing plant and you produce, I don't know, a million cakes, hoping to sell them, and you don't sell them, and in a few days you have to throw them all out. So producing more than you need, or not understanding the market that you're producing to, can lead to this problem. Overprocessing, which is adding more refinements than you need to, more features than the features you need to, or even adding more steps in the work that you need to do. All of this creates waste. The obvious defects: something goes wrong, you have to throw it out. You have to go back and do it all over again sometimes. All of this creates waste. All of this generates other waste, because if there is a defect in the assembly line, for example, and you need to rebuild everything from scratch, you have customers who are waiting, for example, and maybe you have a warehouse that needs to get new parts from a supplier, and now you have to wait for them as well. So you don't try not to have as many defects, and something like this is very aggressively treated in the Toyota production system. Whenever there is a defect, it's like the highest priority is to fix it and make sure it never happens again. And then there's skills, which is you have people around who are not being I wouldn't say taken advantage of, but are not being used to their full potential, and they're not you're wasting their talent on, for example, useless work, or stuck in meetings doing nothing. So that I should probably mention that some of this waste might be necessary. Ridiculous example: suppose you have a toilet paper factory that produces gold toilet paper, right? You don't need gold toilet paper to wipe your bum, but it could also be that you have cornered the market for people who really love to wipe their bums on gold things, like Russian oligarchs, Donald Trump, etc., right? So if you eliminate this waste, you could end up losing your market and losing your business. So this would be a waste that's actually necessary. A less stupid example would be, there's some performative work that you might have to do for compliance. It's necessary because you need that certification, or you need to not get that fine in order to operate. Okay, so how does this apply to product engineering and the work that we technical people usually do? So this is not an exhaustive list. I'm going to give you a few examples and a few ways of how to address these wastes. They're not exhaustive. Feel free to interrupt, suggest things that aren't mentioned, and I'll keep an eye on the chat. I don't promise anything, but I'll keep an eye on the chat. So feel free to interrupt. Okay, so transport. How does transport? I mean, we work with code and non-material things. What's transport here? What are we transporting back and forth? It's mostly knowledge. And one of the very common issues that exist in our line of work is handing over stuff. handing over a design. And maybe you have a designer who's working behind closed doors and they do some mock-ups and they jump on your Slack channel and say, hey, here's the link to Figma, good luck. And that's not a handoff. That's a very poor way to collaborate. Ideally, engineering product, and you know the frustration, right? You've been frustrated by this sort of thing because sometimes there are designs that you can't technically make correctly. And then there's a back and forth of negotiation that happens afterwards. That's always painful, and always, someone's always saying, "Yo, engineers don't want to do any hard work," and designers have these unrealistic ideas. So the problem is that really that we're not working together on the problem, and we, instead of working together and talking about it, we're moving stuff around. And obviously, in this case, the knowledge degrades as it's being passed around. So we need to collaborate together to make sure that this happens. In terms of QA, so again, rather than send some production code over to QA to test, QA should actually be the responsibility of everyone on the team. Even if you have a QA role in your team, they should be a champion, but they should not be the sole people responsible for testing. And from this, any sort of intermediaries that you might have, for example, between a customer and the rest of the team, it's very common that sometimes you have someone in the middle, like a product manager or some salesperson, and this is not ideal. Ideally, a team should be able to communicate directly with the customers and the end users. And anything that you do manually is also transport. So if you need to deploy code manually, it's very likely, at least in my experience, it's been very likely that you forget to do something. You forget to run a little script. You forget to change this configuration. And because this stuff is not automated, sometimes it breaks down and it causes delays and it causes to go back and have to fix stuff that you shouldn't have to worry about. Carlos mentioned the challenges of working remotely. So this is one example of transport, because if you work asynchronously, you are transporting knowledge all the time between the team members. So they need to be, if not working physically together, they need to be able to communicate directly when they're remote, directly and constantly, which is why the time zone overlap is so important when working remotely. It doesn't mean that's the only way to work. Sure, you can make it happen in different ways, but it's harder, and you have to be aware of the wastes that you might be generating in this case. One example of this, even in teams that are that overlap their time zones, pull requests. People open pull requests sometimes out of habit, out of a sense of tradition, because they think it's normal. But it doesn't have to be like that. You can do a code review while pairing with someone else, while mobbing. Or even if you do open a pull request, you can get on a call and discuss the pull request in real time with the reviewer so that they're able to understand the context and they're able to approve stuff much more quickly. And another one, again, there are more examples, but leaving stuff unfinished to finish later on, it's always a bad idea, because when you or someone else picks it up, they won't know what it's all about. They won't know what's left to do. Even if they have some idea, some stuff will be lost in transit. So always try to finish what you start. As for inventory, keeping stuff around it, especially that you don't need. Features that you don't use, that your customers don't use, or features that you don't use yet, but are hoping to release at some point in the future, it's a bad idea to keep them around. Release them frequently, even if it's behind a feature flag so that you're able to test with some real users later on. I do it continuously so that you're able to gauge whether this feature is really useful or not. And if it's not useful or used, then it should be removed. Old features in particular are very um, prone to being unused, and sometimes you just leave them around because they might be useful just in case, but it's code that's lying around that nobody uses, and it's just a maintenance headache. Again, unfinished work. Finish what you start, and if you don't finish it, remove it. Another waste of inventory is over provisioning infrastructure. It's important to measure how you're using the infrastructure and scale stuff appropriately. If you can scale them automatically, then all the better. But try not to have more nodes or a bigger CPU than the CPU that you actually need. Especially if you're maintaining something like Kanban or Scrum or whatever, and you have a very, very big backlog, it's not very helpful, especially since you are stuck in constant discussions about how to prioritize the stuff that's in there. If you're wasting a lot of time prioritizing, keeping track of very old tickets, wondering about old tickets that you don't remember what they're for anymore, you're like, I don't understand the context. Maybe some of them have already been fixed. You don't even know. Be aggressive. My recommendation is be aggressive about removing backlog. If you have a story or a bug ticket in there that's, I don't know, over than a quarter long, just delete it. And you might say, oh, but no, there's so many good ideas and so many important bugs in there that I want to keep. But if they're really important, why haven't they been done in the last quarter? And I like what the people at, I think, Basecamp like to say is that a good idea always comes back. So don't be afraid to throw some stuff in the garbage, because if there is a good idea in those user stories, if there is an important bug that needs to be fixed, it will come back. People will complain about it. People will ask for it. My favorite, any non-production infrastructure. So your staging environment is waste. Like, it's not real. It's a pretend thing. So if you have a good observability in your production environment, if you have canary deployments, you are more than capable, and you should be more than comfortable to test in production. Using feature flags, using A/B testing, and not have to worry about having to maintain a replica. That's sometimes not even a replica, it's a bad replica of the production environment. That just gives you a false sense of confidence. And then you have unused and redundant data. If you don't need it, just get rid of it. And again, the stuff about necessary waste, there is necessary waste in redundant data. The backups, you need to keep backups in case something goes wrong. So consider what you have and what you don't need. For the waste of motion, I mentioned the meetings and everything else. So doing manual work is a waste of motion. So if you are testing manually, if you are deploying manually, I already mentioned this at the start in the transport, but if you're doing stuff manually, you are opening yourself up to blind spots and missing something and making or doing something wrong. Try to automate this process as much as you can. And not just that, they're a waste of time, and they're a waste of your time. You could be using your time to do something more important. Multitasking. If you're doing a lot of stuff at the same time and you're switching tracks continuously, you end up, it's tiring, it's exhausting, and you end up not finishing anything because you're always jumping between tasks. It's very hard to be aware of this kind of waste because you're always so busy. And because you're always so busy, you fall into this false sense of assuming that because you're busy, you're being productive. But productivity is measured by the things that you actually finish and deliver, not by the things that you're currently working on and are never able to finish. So limit the work, the current work in progress that you're dealing with, and if possible, establish a vision and the direction so that you know which way you're moving. Necessary meetings, again, love to fit that Carlos talked about. You have to fit, use them. Ideally, no one should be offended by you leaving a meeting that you feel like you don't contribute to or that doesn't contribute to your personal growth. And as always, make the value of the meetings that you're on clear so that the people who are joining them understand what is important or not. For tooling, if you have a tool or documentation that forces you to take extra steps or to read stuff unnecessarily or spend extra time figuring something out, there's room for improvement here. It could be a bad IDE, it could be documentations that might be overly verbose, maybe it needs to be more concise. A favorite of some designers in the age of Figma. It's very tempting to build these high fidelity prototypes that are very much like real apps, except that they're not real apps. And people spend a lot of time tweaking these mockups very precisely, to the pixel, but it's not really, we're not selling mockups, we're not selling prototypes. Prototypes are useful to communicate an idea. It's more important that we talk with each other and make sure that the rest of the team understands what we're building and how we need to build it. And we have a fast feedback cycle between all the people involved so that they're able to understand and provide guidance on what needs to be done. And there's reinventing the wheel. If something is already on the market, something that you can use or buy, maybe you don't need to build it. And it's, again, very tempting for software engineers to build stuff from scratch because they think it's better if they build it themselves. Waiting, again, pull requests, same thing as I mentioned before, pair mob programming is one alternative to an asynchronous pull request. Waiting for requirements is something that in the last few years is becoming increasingly annoying to me. Where you have people who are just sitting around and saying, "Yeah, well, we don't have the requirements for this story, so I can't get anything done. I can start working on this." Yes, you can. The teams should be autonomous. The teams are cross-functional for a reason, so that we are able to define the requirements for ourselves and not be blocked because we're waiting for some external stakeholder to tell us what we need to do. We should be the ones to decide what needs to be done based on the requests and the needs that we see in our customers. Speaking of which, feedback is important. And if you're waiting for feedback, maybe you're not doing frequent enough releases, or maybe you're not talking with your customers frequently enough. Tardiness, being on time for meetings is important. You don't want to keep everyone else waiting. Slow and reliable tools, and it can be the automated tests and deployments that you have. If your tests take 20 minutes to run, as it happened in a project I was on some time ago, it's going to be really frustrating. You're not going to be very productive because you're waiting for these tests to finish. So try to make tests and deployments as fast as possible. If necessary, get better equipment, get better tooling, better apps, better IDEs, whatever, to make your work as frictionless as possible. And then there's useless work. People waiting on other people who are working on stuff that really doesn't need to be done. So eliminating useless work and understanding the value of the work that you're doing, directing the effort to where it matters is important here. Overproduction, unnecessary features, which falls under the header of building the wrong thing right. It could be that it's perfectly implemented, but nobody needs it. That's a huge waste. And when that happens, it means that the team needs to work better on their user research to understand what the market is really actually asking for. Again, context switching, I mentioned it before. We need to finish what we start. We need to limit the work in progress. Building stuff before it's needed. Even though it's needed, it is a problem of prioritization because you're producing stuff that's not the real or the most important thing that you need to build right now. So understanding when things are needed, using Kanban to your advantage here is really helpful. Building useless artifacts. I mentioned the high fidelity prototypes before. That's an example of a useless artifact. But sometimes, documentation, extensive documentation can be a useless artifact. If nobody reads that documentation, why are you writing it? Invisible work, and this is something that I believe Carlos also mentioned. If a team is working on stuff that you don't know about, it's possible that this invisible work is being produced and is not really necessary. So making this work visible so it can be prioritized by the team is really important. Another thing is an unbalanced team. So sometimes you have a team that's way too big and they're building stuff just to keep themselves busy, and they're building stuff that's not needed. That's a problem. Or you have a team that's unbalanced in terms of skills. So if you have more, for example, backend developers, you might see a shift or some tendency to build more backend functionality than it's actually needed when, for example, the customer might be asking for something else. So having the right team size and having some variety in the team skills so that people are always able to work on the correct things, on the things that are actually being requested by the users is important. Overprocessing is also known as gold plating. And the biggest example, or the most common example in software engineering or product engineering is doing too much. Doing something overly sophisticated because it looks good on your CV, it's not usually a good idea. It's very tempting. It's very easy to sell because people love complex things, but it's a pain to build. It takes longer to build. Costs more to maintain, and it's not something that you'll enjoy, or people who inherit your code will enjoy in the future. One thing that helps test-driven development, which is not, as the name might imply, a testing philosophy, it's a design philosophy. It's a way to make sure that you understand what the goal of what you're building is. And when you reach that goal, you know where to stop. And being able to stop when you are building something is super important because building too much is a waste. Scope creep, always tempting to add one more feature before release, make it a little more polished. And sometimes you just need to release stuff before it's actually 100% done. Understanding if you're building the right thing by exposing it to your actual customers is super critical here, because you could be building and you could be releasing a perfect feature, but if you only do it at the end, you're missing out on important customer feedback who might be guiding your feature in a different direction. So even if you're not comfortable releasing, put a feature flag on there, release it to a few test customers and get their feedback early, and hear them and try to understand what their motivations and what their needs actually are. So do it as frequently as possible and always measure what your customers are doing with it. Other favorite of mine is doing technical stories. Technical stories, especially if they're done for their own sake, they don't add user value. They rarely add business value. And if you have someone who's refactoring stuff just because they have OCD, maybe that's not a good uh, use of their time and a good use of the team's effort. So always understand. I mean, it's not that it's forbidden to have technical stories, but always understand what the value of a technical story is if you have it. Pixel perfection again. Oh, you can't release that because that button is not the right shade of blue or whatever. Uh, this is too much. Like you can always fix stuff later, and you're missing out on customer feedback. You're missing out on the market value of the app by not releasing something, by delaying the release of something. So these features are important, and if they weren't important, you wouldn't be building them in the first place, right? So if you're building something, release it, unlock the value of having built and worked on it, and then you can always, it's never set in stone. You can always go back and improve things. Configuration is a favorite of teams who don't do their user research, and so they think that putting some configuration in solves the problem. And it's very tempting to add some configuration and let the user figure it out what they want. And that way we have a sophisticated system that can do almost everything if you configure it right. But configuration carries a lot of overhead. It carries a lot of maintenance costs. Configurations then, they start to interfere with each other. They cause conflicts. They cause problems. It's more work even for the user who has to configure stuff. So try to hold back on configuration. Always think that you're not going to need it. Do the user research that's necessary to understand what the users actually want, rather than let them configure and figure it out for themselves. Because the maintenance costs of keeping these configuration systems are way high. And another example of overprocessing is adding extra steps to the work that you do. So if you have someone who needs to, I don't know, approve some pull request, or needs to review a product feature before the feature is released, that's an example of gatekeeping. And these things should happen within the team. These checks should happen within the team so that you don't have to wait for external partners and do extra steps to be able to deliver. So always be delivering, and if it's all done within the team, it happens much more smoothly. For defects, I'm going to open most of them all up because bugs, support requests, losing data, downtime. This kinds of things can happen, and usually the way to address this is to automate the tests and always understand what is at the root cause of these issues. If you don't understand the root cause, it's very likely that these things will happen again and that you will not be prepared to either mitigate it or prevent them. So spend some time, whenever there is at least a bigger problem, to do something like a post-mortem, where you try to dig deep and understand why something failed in the first place, and put the stuff in place that, so there's two ways to address it. You could put the checks in place to prevent it from happening again, or you could put in the necessary automation to make the system recover automatically from these failures, and so you don't suffer from them. There's other types of defects that are not related necessarily with stuff going wrong. I mentioned before, you could be building something you can be building it right. You can build something that's perfectly implemented, but it's not the right feature. It's not something that the customer is asking for. And that is a defect as well, because it means that your product is not usable by this customer. And finally, there's skills. So it happens that some people on the team are consumed by this useless work, manual work. Very often, they're testing stuff manually. they're deploying stuff manually. They're working on some infinite refactoring or some infinite reimplementation, um, and they're not available to help the team out with their expertise and their knowledge. And it's a waste of their talent and a waste of their time. So always try to automate whatever you can and understand what you're working on. Also very common, I see this a lot, uh, leaving people out of decisions and discussions. And it happens sometimes even with a designer working by themselves, doing some designs before behind a locked door, and then coming to the team and saying, "Hey, here it is." So this leaves the rest of the team out, and people are not really talking to each other, and they're not really uh, understanding the problem together and coming to a solution together. Um, so try to include everyone in discussions, in meetings. And again, love to feed applies. So include them, but don't make them required so they can decide whether or not to participate themselves. So it's a balancing act. And it's up to individuals to decide whether they're bringing some value to the discussion or not. Restricting creativity, this happens a lot. Sometimes you have a stakeholder who decides what the product is going to be like, or you have a designer who decides what the product is going to be like, or you have an engineer who decides what the product is going to be like. And because you're not making these decisions together, it's a single person, like I don't know, a software architect somewhere. You're not leveraging the expertise that already exists in the team to look at the problem from a different perspective, or try to even just explaining the problem to a non-technical person. It's a bit like rubber tacking. It will allow you to see the problem from a different lens. So restricting your creativity, like by not involving people, by not allowing them to participate in these discussions, is also very, very, very common. And this is very tight. I mentioned before waiting for requirements, and this is very similar, because if you have some product manager or some lead lead developer writing the user stories for the rest of the team and prescribing a solution for the rest of the team, people are going to pick that story up and they're going to do what it says on the story. They're going to do what the requirements say, and they're not going to think for themselves. And I mentioned this, the just following orders. So we need to foster critical thinking and encouraging people to go out and find solutions for themselves, and making sure that their feedback is appreciated and valued. Buzz factor is important. Pair programming helps a lot against buzz factor, especially if you have people working across disciplines. So if you have like a front-end developer and a back-end developer, even if one doesn't know React and the other doesn't know Go, by working together, they can learn something from each other. And we limit the risk of the team stalling when one of them goes on vacation, or one of them gets sick, or goes on parental leave. It happens a lot, more than people maybe realize, and the team cannot stop because the expert is out. So understanding how you build a team in the first place, so that you have a good mix and match of skills, and that you have some overlap, so that they're not talking complete gibberish to each other, is always good. And then pairing and actually collaborating on the problems is critical. And there's a lack of knowledge. Carlos also mentioned this. So talking in a private channel, talking to each other privately, we're leaving people out of these conversations. So sharing with the team, sharing what you know with the team. Again, pairing and mobbing are super important. And even more important than a training session, for example, because you'll learn more, you can learn more by doing stuff together, building stuff together, than you can by some academic training course that might not have a lot of relevance to the work that you're doing. So these are a few examples. I don't have a lot more, and I think we're a bit over time already. So if you have any comments, if you have any examples from your day-to-day experience that you want to share, feel free. And if there's something else that you think was missing from these examples, I'd like to hear it now.